Governance. For most of us, that word it's synonymous with bureaucracy, with red tape, and with that long, slow, grinding sound of a big organization saying no to anything new. It used to be simpler, or at least we thought it was. It was about protecting static assets. Rows, columns, documents just sitting there, perfectly still in a database.
But that world is gone. I mean, it's completely vanished. That whole governance model, which was built for deterministic analytics, where data was a fact and truth was just binary, yes or no, it's just fundamentally obsolete in this age of intelligence. We're seeing this radical transmutation. Governance is no longer about protecting inert data. It's about assuring the integrity, the reliability, and increasingly the existential safety of these probabilistic systems.
And that is the tension. That's what we're diving into today. This is all about the huge disconnect between the strategic blueprint on one side and the catastrophic struggle on the other.
Right. You've got the idealists.
Exactly. The idealists crafting these beautiful, sophisticated architectures, DAMA, data mesh, data fabric, all promising perfect control. But then you look at the real world, and what do you see?
You see a mess.
You see massive, completely avoidable failures. Change Healthcare, Uber, the recent Snowflake breaches. It's a graveyard.
And when the system you're supposed to be governing when it can plausibly lie, when it can hallucinate, governance stops being a compliance exercise. It becomes a core engineering discipline. It becomes a necessity for business survival.
Yeah.
Our mission here is to give you the shortcut to understanding this strategic shift. Why are policies moving from a binder on some executive shelf to automated computational code that's embedded right into the data pipelines?
We're investigating the blueprint versus the bloody battlefield.
Yes.
And by the time we're done, you'll know not just what the ideal structure looks like, but why ignoring it leads to that graveyard of good intentions and multi-million-dollar failures.
So, to start with that ideal, we really have to look at the scaffolding for any modern data strategy. And that's the data management body of knowledge, or DAMA, DMBOK.
Okay.
If you are building any kind of large-scale data capability, this is the foundational reference. It basically defines the entire universe of data management.
It is the definitive reference, I'll give you that, but for anyone who's not initiated, that famous DAMA wheel, it looks incredibly complex.
Yeah.
It's this geometric thing with a hub and spokes.
Yeah.
It feels like something designed in a conference room, not something that's supposed to actually work in the real world.
Well, its complexity is its utility. The diagram places data governance precisely at the absolute center, and it's orchestrating 10 surrounding knowledge areas. We're talking everything from data quality and data security, all the way to data architecture and data modeling.
And the analogy is?
The analogy we use is that governance is the central nervous system of the entire data enterprise.
I get the metaphor, but let's unpack the functional difference there. The center versus the spokes. The spokes are the doing, the execution part, right?
Right. Exactly. The 10 areas around the outside are the execution arms. So data security encrypts things, data quality monitors things, data architecture plans the structure.
Got it.
But governance, sitting right there in the center, is the deciding authority. It sets the mandate, it sets the priorities, the controls, and the monitoring standards for every single one of those spokes.
So without that central nervous system.
They don't coordinate. They just become 10 separate warring kingdoms.
And that failure of coordination, that's where the technical debt starts piling up, isn't it? That's where you start getting that strategic misalignment.
Absolutely.
Can you ground that orchestration role in a specific example, maybe through data architecture?
Sure. Let's consider the decision of whether to use a data mesh or a data lakehouse. That's an architectural decision, but it has these profound governance implications. Governance has to mandate the standards. It decides the long-term strategic direction. So, for instance, it might require a data mesh approach to federate ownership and scale accountability across the business. If governance doesn't step in and enforce that, well, you just get individual teams adopting whatever tactical fix they want.
A new cloud database here, a new visualization tool there.
Exactly. And the entire enterprise structure just becomes this patchwork quilt that nobody can manage.
And if you let that lack of standardized data modeling go on, you get what the sources call the Tower of Babel syndrome.
Semantic fragmentation. It is a core organizational failure. Governance must enforce standardized definitions for your core business entities.
Like customer.
Like customer. It's a classic example. You ask a business leader, what does customer mean? Sales might say, oh, anyone in our CRM. Finance will define it as any entity that has paid an invoice in the last quarter.
And marketing's definition is totally different. Anyone who signed up for our newsletter.
Right, and if those core definitions conflict, every single report you run, every AI model you try to train, every executive decision you make, it's all going to be based on fundamentally conflicting versions of reality. You're paralyzed by your own internal disagreement.
So the Governance Council's job is basically arbitration.
Arbitration and enforcement. It forces alignment. It defines the single authoritative definition of customer. And then it makes sure that the data quality spoke, the data architecture spoke, and the data security spoke all stick to it.
Okay, here's the realist challenge, though. This blueprint is beautiful, but it assumes a perfect organizational culture. When I look at this structure, I see the immediate danger of bureaucracy. If that central governance council gets bogged down in political infighting, or if it just moves too slowly, those 10 knowledge areas will become 10 silos no matter what the demo wheel says. So, does the blueprint itself create the bureaucracy, or is that just a symptom of bad leadership?
I argue the structure itself is agnostic to culture. It just provides the necessary framework for accountability. The danger, as you're pointing out, is when that accountability mechanism, the governance council, becomes a blocker instead of an enabler.
Yeah.
But the failure isn't the wheel, the failure is the velocity of the center. If governance isn't classifying assets correctly, the data security team has no idea what to protect. If governance fails to provide clear retention policies, the storage team can't comply with GDPR's right to be forgotten.
So the framework just exposes the failure. It doesn't cause it.
Exactly. It shines a big bright light on where the problem is.
Okay, we need to spend a little more time drilling into the difference between governance, management, and compliance, because this is where a ton of organizational friction happens. People use these terms interchangeably, but they are very distinct roles with distinct drivers and distinct questions.
We can use that three-way table analogy, the one based on government functions. It's really the most effective way to understand the separation of duties.
Okay, let's hear the breakdown.
Data governance is the legislative and the judicial branch. The key strategic question it asks is, who has the right to decide? The driver here is strategic business value and alignment. Governance defines the policy.
In data management, that's the executive function.
Exactly. Data management is the implementation arm. It's typically done by IT, by engineering, by the DBA teams. The key question here is much more tactical. How do we implement the decision? And the driver is all about technical efficiency and requirements.
So governance decides, management implements. Give me that strategy execution divide with a concrete policy example. Walk me through the layers.
Okay, start with the governance policy. All sensitive non-public data must be encrypted at rest and in transit. That's what in the why. It's driven by risk and business strategy.
Right.
Then data management steps in. The engineers write the code, they configure the necessary services, let's say activating AES 256 encryption on their AWS S3 buckets, or setting up the TLS certificates for transit. Management focuses on the technical spec required to satisfy that governance mandate.
And if that governance mandate is weak or vague, then the management team might implement some outdated or insufficient encryption standard. They think they've checked the box, but in reality, the risk is still incredibly high.
It has to be specific, yes. Governance must specify the acceptable level of technical protection.
Okay?
And then finally, you have compliance. That's the audit and assurance function. The key question for them is simple. Did we follow the rules? The driver is usually external legal mandates, GDPR, CCPA, IIPA.
And compliance has traditionally been reactive. You file the report, you pass the audit, you breathe a big sigh of relief and forget about it for another year.
It was a fire drill.
But what the sources are pointing to is this fascinating blurring of that line, especially with these huge regulatory pushes, specifically the European Union's AI Act.
The EU AI Act is completely rewriting the playbook. Compliance used to be about retrofitting assurance after you've already deployed something. Now the AI Act mandates deep, proactive technical governance. For any high-risk AI system, we're talking things used in critical decision-making, you are now forced to demonstrate things like detailed data lineage, high-quality, non-biased training data, and comprehensive logging. And you have to do all that before the model ever goes live.
So compliance isn't just auditing whether you follow the rules anymore. The rules themselves are now forcing you to change your entire architectural strategy. The legal requirement for, say, explainability forces you to adopt technologies like open lineage and rigorous versioning, which are fundamentally governance practices.
It's a virtuous, but let's be honest, expensive loop. Effective governance, when it's driven by a clear strategy, naturally generates the robust, audit-ready evidence you need for compliance. When organizations treat compliance as just another reactive fire drill, they're basically building their systems without a structural foundation, and they end up paying exponentially more to retrofit these capabilities later on.
Okay, so that's the machine. Let's talk about the people.
Right. Governance is fundamentally a socio-technical discipline. The perfect Dhamma wheel is useless without the human structure of accountability to make decisions and enforce all those policies. And that structure is built around a triad: the data owner, the data steward, and the data custodian.
And it's all designed to enforce the separation of duties.
Precisely.
Let's establish the hierarchy then, starting with the owner, who is fundamentally the person bearing the risk.
The data owners are your senior business executives. The VP of Marketing, the Chief Risk Officer, they are the legislative body. They don't actually touch the data, but they hold the accountability. They define the requirements for quality and security based on business need, and crucially, they control the budget. They're the ultimate deciders of risk acceptance.
And because they hold that risk, their immediate natural instinct is often risk aversion. They want to lock everything down, say no to everything, which instantly creates friction in a big organization that's hungry for data to drive innovation.
And that tension is the central battleground for governance. The governance councils are designed to mediate exactly this, to ensure that the owners implement policies that protect the data without completely paralyzing the business.
Okay, so next up are the data stewards. I see them as the most critical role, really. They're the operational bridge, the people who actually translate that abstract policy into operational reality.
They are the civil service and the police force, all rolled into one. Stewards are the subject matter experts, the SMEs. They are hands-on, and they deeply understand the semantic meaning of the data.
So if the owner mandates high-quality customer data,
The business steward is the one who defines that. They say, okay, a high-quality customer record requires a non-null validated email address, a unique ID, and it must be updated within 48 hours of any transaction. They make it real.
and we break stewards down, right? You have the business steward who focuses on what the definition is, and then the technical steward who focuses on where that definition physically lives.
Precisely. The business steward manages the glossary, they resolve data quality issues that start with business process errors, and they're the ones who approve access based on the requester's actual need. The technical steward, who often sits with IT, makes sure the physical implementation, the database column types, the API schemas, aligns perfectly with what the business steward has defined.
And finally, the data custodian. The technical guardians, they are purely execution.
Right. The custodians are the engineers, the DBAs. Their job is the safe technical custody of the data. They manage storage, they run backups, they apply encryption keys, they patch the systems. They're told what encryption to use by governance, and they're told who to grant access to by the steward. Crucially, they lack the business context to make those access decisions themselves.
And that separation of duties owner defines, steward translates and approves, custodian executes. That's where the whole system commonly fails, especially in immature organizations.
The most common failure mode is forcing the custodian to take on the role of the steward.
Yeah, the owner's too busy, or the steward position was never even filled.
Exactly. So an analyst needs access to the sensitive customer profile table. The request lands in the DBA's queue, the custodian's queue, and they have to approve it. The DBA has no idea what the requester's risk profile is, or why they even need the data. All they know is the SQL syntax.
So the DBA is forced to make this strategic risk decision that they're completely unqualified to make. It breaks the chain of accountability and introduces this huge security risk because, let's be honest, they tend to just grant access to avoid friction.
And this failure doesn't just create security risk, it creates that maddening customer experience that we have all encountered. That is the immediate, tangible cost of bad governance.
The analogy of calling the bank, that universal moment of pure frustration. I've been there dozens of times.
You call the bank about an issue, the first agent is great, you spend 5 minutes confirming your identity, explaining the whole problem, then they transfer you to a specialist.
And the specialist, completely cold, asks you to repeat your name, your date of birth, and your account number all over again. Then you have to repeat the entire story.
It's infuriating.
You're sitting there thinking, I just gave you that information. Why are you not sharing this?
That's poor data governance manifesting as inefficiency. The underlying data probably exists, but the policy for sharing that specific customer session data, the permissions, the access rights, the classification, It's broken across all those organizational silos. The call center, the transfers department, the loan specialist. The system failed to enforce a standard data model and access policy that would allow that seamless, authorized flow of information. The owner failed to mandate sharing, the steward failed to define the business rules for it, and the custodian couldn't build the seamless data flow.
So if you're a leader focused on improving customer experience, the fastest way to do that is often not some new AI chatbot. It's just fixing the broken accountability model between your stewards and your custodians. The frustration your customers feel is just a symptom of your broken policy. All right, let's turn our attention now to the AI earthquake. We've established this ideal human structure, but how does that hold up when the intelligence it's supposed to govern is now stochastic, it's probabilistic, and it's fundamentally unreliable in a way that static data never was?
Traditional governance is built on this idea of binary truth. A fact is either correct or it's incorrect. Generative AI, LLMs, they introduce that devastating third state, plausible but fabricated, the hallucination.
And that's an existential governance crisis, especially when these systems start moving into high-risk domains like medical diagnostics or legal advice.
The problem is that our traditional metrics for data quality, completeness, accuracy, they're just not sufficient anymore. It's not about checking if a cell in a spreadsheet is empty. It's about acknowledging that the model is an opaque black box. It's a stochastic engine that might spit out unsafe output at any moment.
So governance has to shift.
Exactly. It has to shift from just validating static records to actively monitoring output distributions and probabilities. And to manage that opacity, that black box, the governance mandate must enforce explainable AI, XAI practices, not as an afterthought, but as an absolute architectural necessity.
And XAI translates directly into specific mandated governance artifacts like model cards and system cards. What makes these documentation requirements so critical to governance? Why aren't they just, nice to have engineering notes?
Because they are the required contract with the Governance Council. A model card documents the model's architecture, its training data sources, its performance benchmarks, and, crucially, its intended limitations.
For example,
this model is only validated for English language text summarization. The system card goes even further. It documents the entire production deployment, including the monitoring regime, the risk classification, and the human oversight mechanism. So even if the neural network pathway itself is opaque, these documents fulfill the regulatory requirement for traceability and accountability.
This also directly tackles the growing problem of data leakage, right? Since these LLMs internalize PII and trade secrets during training, they can just regurgitate sensitive information when prompted. And they can bypass traditional data loss prevention, or DLP, tools.
Right. DLP, which just scans for standard patterns like credit card numbers and emails, is completely blind to synthetically generated sensitive data that's embedded within some plausible narrative.
So what's the governance solution?
The governance solution is mandating a strict separation of the training environment and pushing organizations toward retrieval-augmented generation, or RAG, architectures.
RA is an architectural move, but why is it a governance win?
Because RAG shifts the risk from the model weights to the external knowledge base. So instead of baking the data into the model retrieves facts in real time from a secure vector database.
I see.
And since that vector database can be layered with all the existing governed access controls, the policies we defined earlier, the model will only retrieve information that the querying user is actually authorized to see. Governance moves the protection layer from the opaque black box to the transparent, auditable database.
Okay, let's talk about the dynamic nature of AI.
We have to. Unlike traditional systems, AI models degrade over time. It's a phenomenon called model drift. If the world changes, the model's performance slowly, silently erodes. Governance has to be able to spot this silent decay.
And this is where data lineage, which used to be this bureaucratic documentation exercise for data warehouses, it becomes the model's immune system. It's constantly tracking the health of the entire pipeline.
And it becomes exponentially more complex because lineage now has to track the MLBM, the machine learning bill of materials. If you discover bias or poor performance in your model, governance must be able to trace it back not just to a source table, but to the specific version of the training data set, the specific pre-processing script that was used, and the exact environment the model was trained in.
So that means rigorous versioning of data assets, not just your code.
It's non-negotiable.
And the realist in me hates the idea of a human trying to monitor for silent drift. I mean, this has to be computational governance to work at any scale.
It absolutely does. The policy can't just be a rule written on paper, it must be an automated sensor. Advanced governance frameworks mandate monitoring the KL Divergence Score.
The KL Divergence Score, wait, let's give a clear analogy for those who aren't deep in the MLOps weeds.
Think of the KL Divergence Score as the tire pressure warning light on your car. You don't need to know the exact mathematical complexity of the divergence calculation. What matters is that the governance team has set a threshold. This score measures the statistical difference between the distribution of the data the model was trained on and the distribution of the live data the model is currently seeing in production.
So if the model was trained primarily on data from, say, Q1 of 2024, and suddenly the live production data in Q3 looks wildly different because of a new product launch or a big market shift, the KL Divergence Score spikes.
And if that score exceeds the threshold that's been mandated by the governance policy, that's the red line on your dashboard, the system doesn't wait for a human to notice that the model's performance is dropping. It automatically flags the model, it triggers an alert, or it might even initiate a controlled pipeline stop until a data steward can review the input data. That is computational governance preventing silent failure.
This brings us directly to bias, which, as we said, is fundamentally a data quality problem disguised as an ethical one.
Right. If a system is trained on historical loan approval data that reflects past discriminatory practices like historical redlining in certain neighborhoods, the model will learn and then scale that historical injustice, even if you mask the geographic features.
So governance has to mandate a check that goes beyond just completeness.
It has to check for representative quality.
Give me a detailed example of where a 100% complete data set is still just organizational garbage because it lacks that representative quality.
Okay, imagine a massive data set that's used to train an HR screening tool. Every single field name, resume, text, experience rating is complete. It's technically perfect. However, 95% of the data reflect job applicants from 2 specific high-wealth zip codes, and it completely excludes applicants from rural areas or low-income districts. The model will learn to subtly penalize the resumes of that excluded population simply because they deviate from the learned norm. The data is complete, but it is completely unrepresentative of the global workforce you actually intend to hire from. Governance has to mandate statistical testing to ensure the dataset accurately reflects the diversity of the population the model serves.
Okay, so if model drift is a slow internal sickness, then data poisoning is a direct, malicious attack on the decision-making intelligence itself. This goes way beyond just stealing data. This is about corrupting the very source of truth.
This is the existential risk. The attacker seeks to compromise the model's integrity so that your decisions are flawed. And that could lead to financial losses, medical misdiagnoses, or even physical harm.
Let's get into the mechanics, starting with a really insidious one, split view poisoning.
Split view poisoning exploits the gap between the audited environment and the live environment. The attacker injects these subtle, malicious data points that cause the model to fail, but only on specific, targeted inputs. Say, classifying a specific competitor's logo incorrectly while maintaining high accuracy on all the general benchmarks. So the human auditor who's running standard performance tests sees high accuracy, sees compliance, but the targeted attack still works perfectly in the wild.
And then there's the threat that keeps security chiefs awake at night, the sleeper agent or backdoor attack. This is corporate espionage using AI.
It is the perfect software weapon. The attacker trains the model to include a secret trigger. This can be a specific phrase, a set of pixels, a unique signature that they embed into the training data.
And the model operates normally.
Flawlessly, for months or even years.
Yeah.
Then, when the attacker introduces that specific trigger phrase in a prompt, the model bypasses all of its safety filters and executes a malicious payload, approving a fraudulent invoice, exfiltrating hidden data, or providing a misdiagnosis.
And traditional firewalls, antivirus software, they're all useless because the vulnerability is baked right into the model's learned behavior. So how do you defend against something so subtle?
The defense has to be governance-based supply chain security. You have to strictly control and audit the entire data supply chain that's feeding the model. This is where governance mandates the creation of pristine, untouchable truth. We call them golden data sets.
These golden data sets are the sacred truth, the standard against which all other data is measured.
Exactly. Governance teams have to maintain these small, cryptographically signed, human-verified data sets purely for continuous benchmarking. If a model's performance on this pristine data set suddenly drops, even just marginally, it signals a subtle shift. That's likely poisoning or a severe drift. This kind of automated testing is the only way to detect a sleeper agent before the trigger gets pulled.
And we come back to AGE, retrieval augmented generation, because while it helps solve the leakage problem, it opens up a whole new attack surface for poisoning the vector database itself.
The governance policy has to pivot again. If an attacker injects a maliciously constructed document, say, a fake safety manual that subtly encourages dangerous behavior into your vector database, the LLM will retrieve that document and it will incorporate its malicious content into the response.
Even if the model weights themselves are clean.
Correct. So governance has to extend strict integrity checks, access controls, and data validation directly to the vector stores and the pipelines that embed documents into them. You are now governing the source material for the intelligence, not just the intelligence itself.
Okay, so given all that complexity, the scale and the distribution of data in the modern cloud have made that old school, centralized manual governance just impossible.
Completely impossible. To cope with this, the industry has really fractured into two dominant architectural philosophies, and each has a radically different approach to how governance gets applied: the data mesh and the data fabric.
This is the governance schism decentralization versus automation. The data mesh is the socio-technical approach, pushing ownership out to the business domains.
Right. The data mesh treats data as a product. So the marketing domain owns and operates its customer data product, the finance domain owns its revenue product, and so on. Governance becomes federated. You have a central council that defines the global standards, the rules of the road, but then each domain decides how to implement those standards locally. That gives them velocity and specialized accountability.
My realist alarm is just blaring right now.
Yeah.
Decentralization sounds suspiciously like a recipe for chaos in a large enterprise. If every domain is implementing the global rule their own way, how do you prevent the rapid creation of incompatible new data silos where the standards are, honored more in the breach than the observance?
And that is the central legitimate critique of the data mesh. It requires extremely mature, disciplined teams and perfect adherence to that global contract. The alternative, the data fabric, it tries to solve that scaling problem with centralized automation.
Tell me about the fabric. It sounds like the pure technocratic solution.
The data fabric is technocentric. It uses a unified layer of active metadata and AI to virtually stitch together all your disparate data sources, cloud lakes, traditional databases, streaming systems. The data doesn't have to be physically moved. The fabric creates a single governed access point that's managed by centralized intelligence.
So instead of physically moving data and federating ownership, you just virtualize the access and centralize all the governance logic.
Exactly. The fabric's knowledge graph automatically applies policies. So if the fabric detects a new data stream containing masked PII, the active metadata tags it as high sensitivity, automatically updates the catalog, and enforces encryption, all without a human data steward having to intervene. The policy enforcement is perfectly consistent because it is centralized in the fabric's engine.
Okay, so now we have our debate. The idealist mesh promises scaled velocity through distributed human accountability. The idealist fabric promises perfect consistency and lower friction through centralized automation. But that centralized automation, it worries me. What happens when the fabric's knowledge graph itself gets poisoned? You've just created a single point of governance failure that poisons every downstream asset all at once.
That risk is absolutely present. The integrity of the fabric relies entirely on the integrity of that active metadata layer. If an attacker compromises the fabric's centralized policy engine, the damage is enterprise-wide and it's instantaneous. This is why neither architecture really wins outright. They're starting to merge through the requirement for federated computational governance.
Okay, so this convergence is only possible through this idea of policy as code.
Right. This is the mechanism that automates governance enforcement. It's what allows a large organization to set a global rule while still deploying it locally and consistently across hundreds of teams and thousands of data products.
So the policy document is no longer a PDF sitting on a SharePoint site. It's a script that runs every single time code is deployed or data is queried. And if the script fails the governance check, the deployment is blocked. That's the computational part.
And the industry standard for making this operational is the Open Policy Agent, or OPA. OPA is brilliant because it completely separates the policy decision from the enforcement mechanism.
Okay, walk us through the workflow, because this is where the theoretical ideal actually becomes a deployable reality.
Okay, imagine an analyst. They're using a query engine like Snowflake. They try to access a highly sensitive table. The query engine acts as the enforcer. And it sends a request containing the user's role, the data's sensitivity tag, the time of day. It sends that to OPA.
And OPA is the decider.
OPA is the decider. It evaluates that request against policies written in its declarative query language, which is called REGO.
And that REGO code determines access or denial. Let's look at that specific snippet we found in the source material. Allow input.user.role analyst input.data.sensitivity.
That one line is the centralized logic. It says, very simply, only permit access if the incoming user is tagged with the analyst role AND. The data they are requesting is not tagged with high sensitivity. The definition of the rule is centralized in OPA. But the actual act of denying or permitting the query is done locally by the query engine, by Snowflake.
That is genuinely elegant. Centralized logic, distributed enforcement. But let me push back as the realist. How hard is that REGO policy to maintain? Business rules change weekly. If governance becomes a bottleneck because the team maintaining the REGO code can't keep up with the velocity of business change, you just move the bureaucracy from a meeting room to a code repository.
That's a critical challenge. Policy debt is replacing technical debt. However, OPA allows for versioning and automated testing of policies, which makes it inherently more manageable than paper. And furthermore, the computational element is strengthened by tools like DBT, the data build tool, which enforce governance upstream.
Tell me about DBT model contracts.
DBT lets data producers define a schema contract. It's essentially an API guarantee for their data product. So for instance, the finance team defines their revenue table contract. This table will always have a transactioned column that is a non-null integer.
Okay.
Now, if the finance producer tries to deploy a change that breaks this contract, say, they accidentally change the column to a string DBT's continuous integration, continuous deployment, the CI/CD checks, will automatically fail the build and the deployment.
That's governance as prevention. The system itself is enforcing the standard. Governance isn't chasing down the team that broke the schema 3 weeks later. The pipeline prevents the break from ever even entering production. This shifts governance from auditing to acceleration.
And to tie this all together, the software that supports governance has had to take this huge leap forward. We have moved from passive data catalogs, which were glorified inventories, to active intelligence platforms like Atlan and Calibra.
So what defines active metadata management in practice?
Active means the metadata doesn't just describe the data, it listens to events and it drives action. It's observability for governance. Instead of running a nightly crawl if a change occurs, say, a schema alteration in Databricks, the active metadata platform immediately triggers a lineage update and sends notifications to all the affected downstream consumers via automated channels.
And the Calibra Protect example, that perfectly demonstrates how this bridges the technical and business divide.
It acts as the operational bridge between the data steward and the data custodian. The steward, using a simple no-code interface, defines the masking policy. Mask all patient emails for users who are not in the clinical access group.
Right.
Calibra Protect translates that high-level policy into the native syntax of the underlying database, Snowflake or Databricks, and it pushes the enforcement natively to the platform. The custodian doesn't have to manually configure complex views. The governance tool automates the entire technical implementation.
And finally, we've circled back to the importance of open lineage. If the EU AI Act mandates traceability, then granular lineage is completely non-negotiable.
It is the data equivalent of a flight recorder. If an AI output is challenged, you need to be able to prove not only which source table was used, but the precise sequence of transformations, the job that executed it, and the data volumes at each step. Open Lineage provides that granular API to capture these job-level events in real time, which fulfills the explicit requirement for auditable data pathways demanded by modern regulators.
Okay, we've covered the ideal. Now let's walk through the messy reality. Because the greatest insights into the necessity of governance come from examining the catastrophic failures that are caused by its absence. These are organizational failures, often just disguised as technical hacks. Let's start with Change Healthcare, February 2024, the ransomware attack. This wasn't just a corporate incident. This crippled 40% of the entire U.S. healthcare payment system. Hospitals couldn't get reimbursed, pharmacies couldn't dispense medicine. It was operational paralysis on a national scale. And the immediate verifiable cost was over $872 million in response and recovery.
And the root cause analysis, once all the dust settled, was almost unbelievable in its simplicity. The attackers entered via a legacy Citrix remote access portal that lacked multi-factor authentication, MFA.
A lack of MFA on a single old portal. How does that happen in an organization of that size and criticality? It's not a technical failure of the core system, it's a governance failure of the absolute highest order.
It is the catastrophic price of integration debt. Change Healthcare had been acquired by United Health Group. The governance failure was the parent company's inability, or maybe unwillingness, to fully integrate every single acquired asset, no matter how small or how legacy, into their strict corporate governance framework.
Right.
Governance mandates comprehensive asset inventory and a non-negotiable MFA policy across all access points. The failure to identify that single weak legacy link was a total organizational oversight.
The lesson here is brutal. Governance has to be universal. The moment you fail to enforce a mandatory basic security control like MFA on even one legacy asset, you create a single point of failure that can shut down billions of dollars of national infrastructure. Governance is the blueprint for operational resilience.
Yep.
Okay, next. Let's look at the Snowflake mass breaches in 2024 affecting giants like Ticketmaster. Millions of records stolen. What's critical here, again, is that the platform itself was not the vulnerability.
Correct. The attackers exploited stolen valid credentials that were obtained through InfoStealer malware on customer employee devices. And nearly every single compromised account was one that lacked multi-factor authentication.
This shifts the blame entirely to the customer's governance failure to enforce identity hygiene. This is a textbook case of failing the shared responsibility model. Snowflake provides the tools for high security, but the customer's governance team has to mandate their use.
And we have to focus on which accounts failed. It wasn't just human users. Many of them were ghost logins, orphaned service accounts, legacy test accounts, or old demo accounts that still had high administrative privileges.
Just slip through the cracks.
They slipped through the cracks because the governance team failed to implement rigorous, auditable decommissioning policies. They were unmonitored accounts with admin keys just sitting there.
So if you are relying on a cloud platform to store your most sensitive data, the governance mandate has to extend with absolute ferocity to the identity layer. Mandatory MFA for all users, human and non-human service accounts, and a quarterly audit to decommission accounts that retain privileges without any active monitoring. If you don't govern the identity, the best database security in the world is moot.
It's useless.
Now, the Uber case. This is less about the technical means of the breach and more about the cultural failure of governance. 2016, 57 million customer and driver records were stolen. But the true disaster was the reaction.
The chief security officer, Joe Sullivan, he made the decision to pay the hackers $100,000, but he disguised the payment as a bug bounty, and then he forced them to sign non-disclosure agreements to keep the entire event quiet.
That wasn't a governance mistake. That was a profound failure of the governance of ethics. The attempt to suppress the breach violated mandatory data breach notification laws across multiple jurisdictions.
And the underlying issue was a culture that valued business velocity and innovation way above compliance and ethical responsibility. The governance structure, which is supposed to mediate that tension between velocity and ethical mandates, was completely ignored in favor of minimizing the short-term business impact.
And the conviction of the CSO for obstruction of justice. It set a terrifying precedent. It proves that governance needs independent ethical authority and serious teeth. When business pressure compromises the governance function, the consequence isn't just a fine, it's potential jail time for the leaders involved. Finally, Equifax. 2017, 147 million records stolen. This was a death by 1,000 cuts. But two specific failures are just the most damning governance examples.
Failure 1. They failed to patch a critical Apache Struts vulnerability. The patch should be available for months. And failure 2. An internal expired digital certificate blinded their network traffic monitors for 10 months. That prevented them from detecting the massive ongoing data exfiltration that was happening over encrypted channels.
So you had a known vulnerability, and you were completely blind to the resulting theft for nearly a year. But the root cause wasn't a lack of knowledge or a lack of tools. It was siloed communication and institutional fragmentation.
The internal alert telling the responsible IT teams to patch the Apache Struts vulnerability was sent to an outdated distribution list. The responsible data custodians never received the notification. They didn't know the asset was their responsibility, or they didn't know the patch was even required.
That is the ultimate governance maxim. You cannot patch what you do not know you own. The governance program failed in fundamental asset management, maintaining a clear, up-to-date inventory of systems and owners and communication protocols. The consequence of an outdated email address was one of the largest data breaches in history.
And these failures, Equifax's communication silo, Change Healthcare's integration debt, Uber's ethical compromise, they all demonstrate that the catastrophe is rarely a failure of the technology itself. It's a profound failure of organizational structure, of accountability, and the inability to enforce clear policies across the human infrastructure.
So, given that gallery of failures, it's clear that relying on voluntary best practices just isn't enough.
It's insufficient, and regulators, particularly in the EU, are now responding by forcing companies to adopt proactive built-in governance through the strategic double helix of the AI Act and the Data Act.
The EU AI Act is the restrictor, focusing on safety and responsibility, especially through the risk-based governance framework.
Right. High-risk AI systems, so things used in credit scoring, policing, or job screening, they now must meet these stringent requirements. This includes using high-quality, representative, and error-free training data and automatically logging every single event and outcome. This regulatory muscle is forcing organizations to adopt the advanced governance practices we detailed earlier, model cards, lineage, and representative quality testing, because the law demands it.
And the Data Act is the opener, focusing on data access and portability.
It mandates that users of connected devices, all IoT devices, must have legal access to the data they generate. This is great for competition, but it immediately creates this massive governance paradox. How do you legally share raw, granular IoT data, which is mandated by the Data Act, without violating the privacy of the user or others, which is mandated by GDPR and other privacy laws?
The implication for architecture is just undeniable. You cannot retrofit the ability to granularly share and mask and port this complex data.
You have to adopt privacy by design. These complex capabilities, automated masking, differential privacy techniques, granular access control, they have to be engineered into the data architecture at the design phase, not bolted on later. The regulation is becoming the structural blueprint. It's requiring proactive governance to be embedded right in the code itself.
So our journey today has tracked governance as it moves from manual processes to automated code.
From centralized bottlenecks to federated accountability.
And most crucially, from deterministic data protection to probabilistic intelligence assurance.
And the ultimate painful lesson drawn from those catastrophic failures like Equifax and Change Healthcare is that these incidents were not technical accidents. They were failures of governance. The inability to enforce mandatory policies, the lack of an up-to-date asset inventory, and the breakdown of basic communication protocols between the human roles.
Right. Governance has to be seen not as a compliance checklist that slows you down, but as the architectural foundation that allows you to accelerate safely.
When policy is clear, when it's enforced by code, and when accountability is built right into the architecture, good governance becomes the single most effective accelerator of innovation your company can possess.
It's the difference between building a fragile house of cards that collapses under the first regulatory wind and engineering a resilient skyscraper that can handle the massive pressure of technological change and market velocity.
We've spent this entire deep dive discussing how human governance must control algorithmic intelligence. We mandate model cards, we write policy as code in Rego, and we supervise the training data to ensure its integrity.
But if generative AI continues its rapid sophistication and eventually becomes capable of not just writing the policy, but implementing it, testing it, and auditing its own Rego scripts, in essence, governing itself, what is left for the human data owner and the data steward to do?
Will the future of governance evolve from enforcing human rules to simply supervising the AI's ethical audit function? Will the human role become reduced to merely overseeing the AI's self-governance capabilities?
That is a profound thought about the changing relationship between human strategy and autonomous intelligence for you to chew on as you map out your path forward. Thank you for diving deep with us.
We'll catch you next time.